Now, to actually create a table, we first have to get a connection to our database using DAL, and then once we have our database connection, here we call it DB, we then invoke on it the method define_table. And with the first argument, we specify the name of the table we're defining, and then after that we have any number of field objects representing the columns of this table. And for each field, we first specify the name and then the type. So here we're defining two tables, the first called cat, the second called cat_owner. And in the cat table, we're giving it 4 columns, a column name of type string, a column age of type integer, and a column weight of type double, and then also a column cat owner, which is a reference to the cat owner table. So this is a foreign key pointing to the primary key of the cat owner table. Notice though, in the cat owner table, we don't define any primary key because, as I said, the DAL will automatically give every table a primary key column called ID, which is an integer. So both the cat table and the cat owner table here have primary keys, we just don't explicitly declare them. Having now defined these tables, the connection object DB will have an attribute for each table we defined. So there's now db.cats, which returns the table object representing that table, and db.cat_owner returns the table representing the cat owner table. And within each table object, you have an attribute representing each column. So within the cat owner table, there's .name, which returns the field object representing that column. So do note there's a bit of a strange asymmetry here, because whereas we create actual field objects which we pass to the define table method, we don't create any table object. It almost would make more sense if we were to create a table object first and then pass that to the define table method, but that's not how it works. I imagine simply for the sake of conciseness. Now, be clear that the end effect of invoking define table is to, 1, actually create these tables in your database, and also to create these table objects which you can then interact with in your Python code. The strange part about this is that you will invoke the define tables method to define your tables in every request, which sounds odd because, wait, you don't want to recreate the tables in the database every single request. That doesn't make any sense. Once we create the tables the first time, we didn't just want to use the existing tables. So what actually happens is, in your application, there's a subdirectory called database, in which are kept files describing the tables of your database, such that the DAL knows when you invoke define table whether or not that table already exists, and whether therefore needs to actually then create them in the database or not. Only when we use define table to create a new table with a new name does the database actually then create a new table. Likewise, we can modify one of our existing tables by simply, say here, just removing one of the fields from the cat table or adding in another field. The DAL will then see that the table as you just defined it differs from how it's defined in the database directory, and so it will then actually alter the table in the database, which in SQL is done with the alter table statement. Now, in the terminology of databases, when we take an existing schema and we modify or remove one of the existing tables or one of its columns, that's what's called a migration. It's an altering of the schema. I believe it's called a migration because usually it's used in the context of taking data from one database and putting it into another, so there's like migrating from one database to the next. But the term also came to be used in reference to just altering an existing database itself, not just moving your data from one database to another. Basically, a migration means we're changing the structure of the data, and that can be problematic because sometimes you can't just take, say, an existing column and convert all of its values from one data type to another. So while in some circumstances we can successfully and without error perform what's called a auto-migration, basically a migration that's done for us automatically, but in other circumstances we can't get away with an auto-migration because the database is not smart enough to handle the changes for us, or we're going to end up losing data if we try and do an auto-migration. So by default in Web2Py, auto-migrations are enabled, but there's a configuration setting where you can actually disable them, or you can actually disable them on a table-by-table basis. The defined table takes an optional named argument, migrate. If you specify an argument of migrate equals false when you define a table, that will stop the DAL from even trying to create or alter the table as it exists in the database. It will just assume that the table is as you defined it with the define table method. So the problem there, though, is that there might be a discrepancy, and you might get an error later on when you try and actually use that table if it doesn't conform to the definition as you laid out with the defined table. But at least it does ensure that you won't harm your data, so that's why you would set migrate equals false. So to restate what defined table does, it creates a table object and assigns it to an attribute of the connection object, so like db.cats here, but then also it will actually create that table if the table doesn't already exist, or it will modify the existing table of that name if it doesn't conform to the definition we just specified with defined table. Now, once we have our table, we want to put data in it, and we do so with the insert method of the table object. So here we're invoking db.catOwner.insert, and the insert method expects a named argument for each column. So our cat owner table has two columns, name and address, both strings. So we provide a name argument and an address argument. And this inserts a new row in the cat owner table. And remember that every table implicitly has a primary key column named ID of type integer, but that's automatically set. So we don't specify an ID because the database is picking an ID for us. The other notable method of the table object is drop, which when invoked will actually remove the whole table from the database. Of course, removing tables isn't something you commonly do in the normal course of an application, but it's there if you need it. Now, to select, update, or delete rows from your database, you need to first create what are called query objects. And the primary means we have for creating queries is not to invoke the query constructor itself, but to actually use these overloaded operators of the field type. The field class has operator methods for the equality operator, the not equality operator, less than, greater than or equal to, less than or equal to. So when you use those operators and the left operand is a field object, what you get back is a query object. So we have three examples here. The first expression, db.cat.id greater than 0, well, first db.cat gets you the table object, and in that table object we have a column ID, which is the primary key of that table. So db.cat.id is the field representing that column. And as I just said, the field type overloads the greater than operator, so given the way overloaded Python operators work, this is actually invoking the method gt__ of the field class, and it's passing to it first the field itself, and then as the second argument the value 0. And what the method returns, what this expression evaluates into, is an as yet unperformed select, delete, or update statement in which we are selecting the rows from cat where cat.id is greater than 0. So to be clear, this just creates an object representing the as yet unperformed select, update, or delete. Likewise, in the second line, first db.cat.id, that's a field object representing the ID column of the cat table, and when we use the equality operator on a field object, when field is a left operand, that's actually invoking the method _eq_ of the field class, and to that is being passed first the field object itself and then the argument 4. So what we get back is a query object representing all the rows in cat where the ID value is 4, which of course should be just one row because multiple rows aren't supposed to have the same ID. IDs are supposed to be unique. In the last example here, we're again using the equality operator, except now both arguments are fields, not just the left operand. db.cat.catOwner, that is the foreign key column cat owner in the table cat, and db.catOwner.id, that's the ID column in the cat owner table. So the query object that results represents a selection of rows from the joining of these two tables, because we're involving columns from two separate tables, so of course they have to be joined first. So it does an inner join between cat and cat owner, and then we're filtering from that join the rows in which cat.catOwner equals catOwner.id. So note that the thing a bit peculiar about how we express queries in the DAL is that the joining of tables is sort of left implicit. It's like we're just specifying predicates to filter, and then whether tables get joined together, that's just implied from whether there's more than one table involved. If you just have one table, no tables need to be joined, but because the expression here involves two tables, both cat and cat owner, well, they have to be joined first. So in the query, the join is implicitly there. Now, to actually use these queries to do an actual select, update, or delete, we first have to wrap the query object in a set object, because it's the set class which actually has the methods select, update, and delete, which, as I discussed earlier, I believe is actually just a mistake in the API. The query object itself should have just had these methods itself, but for whatever reason, this unnecessary complication made it in the early days of Web2Py, and it's stuck around since then. So here in this example code, the first line, we're creating a query object with the expression db.cat.id equals 2. Remember, db.cat.id, that's a field object. The equality operator then is overloaded for field objects, and that method actually returns a query object, which we're assigning to the variable query. The parentheses around the expression here are not necessary, I just included them for clarity. And then in the next line, the way you get a set object wrapping the query is you pass query to an invocation of the connection itself. It's kind of strange. You don't pass it to a set constructor. Rather, our object representing our database connection, DB, is an instance of DAO, and the DAO class includes a method called _call, and that's effectively overloading the function call operator itself, which is a pair of parentheses. So when we invoke the connection object DB as if it were like a function, what we're actually doing is invoking that call method. And so query is being passed to that call method, and what it does is it returns a set object wrapping the query. So not only is this a step which should be unnecessary, it's done in a very strange way. The justification for this oddity, I assume, is that at the time it seemed like the syntactically most compact way of expressing this common operation, rather than having to create some other method to which we pass both the DB object and the query object. You could just invoke the connection object itself and therefore not have to pass it in also as an argument. But again, for whatever reason, that was a mistake, because the query object already contains information about the connection, because these field objects belong to tables and tables belong to connections. So the query object should have encoded within it knowledge of what the connection object is. So we don't need to introduce it in this very convoluted way either. All the information that's needed is there in the query object. And I guess for whatever reason, when Massimo first created Web2Py, he just didn't see this, and so he missed this opportunity and introduced this unnecessary complication, which is just stuck around. But anyway, so we have our set object, and now we want to actually perform a select, update, or delete. Well, say we invoke the delete method, that then performs a delete of all the rows in the cat table where cat ID equals 2. If instead we were to invoke update, we would specify a named argument for each column we want to update, and so we'd write lives equal 8 to set the lives column to the value 8, name equals fluffy to set the name column to the value fluffy. So this invocation of update will modify all the rows in the cat table where ID equals 2, which again is presumably just one row, and so the values of lives and name in that column get updated due to the values 8 and fluffy respectively. Now, with the same query object, if we were to invoke the select method with no arguments, that would perform a select and return the results as a rows object. And because this would be a select over the cat table in which the ID column equals 2, that should again be just one row. And to get the individual rows from a rows object, we use the subscript operator just like a list. So rows subscript 0 here will return the first row, the first and only in this case. And then with the row object, we can then access the columns by an attribute of the same name. So row.lives here is an expression that should evaluate into whatever value lives has in the column where the ID equals 2. Now, if you don't want the select to return all of the columns, you can specify which columns you want by passing field objects to the select method. So here we're just selecting for the columns name and lives of the cat table. And so if we then try and access some other column in one of the row objects, well, that will throw an exception because there is no such attribute because we didn't request it in our select. So here, row.wait should throw an exception because the row has no such attribute because we didn't select for that column. Lastly, an important thing to keep in mind about row objects is that if the query involved multiple tables, well, then you might get name collisions between columns of the respective tables. So when your query involves multiple rows, the column values get stored as attributes in storage objects named after the tables. So in our row here, to get at lives of the cat table, we write row.cat.lives. Row.cat here is a storage object representing all of the columns of our query from the cat table. For the sake of more complex queries, the query class overrides the ampersand and pipe operators, which effectively then are the and or operators respectively. So if you want to AND two queries together, you connect them with the ampersand operator. If you want to OR them together, you connect them with the pipe operator. And then query also overloads the tilde operator to negate a query. But this is a unary operator, not a binary operator, so it always has just one query argument. So we're taking the query object representing cat.catOwner equals catOwner.id, and then we're negating that. So we're filtering for the rows in which cat.catOwner is not equal to catOwner.id. So expressed in terms of SQL, that would look like cat inner join catOwner. There's an inner join because there's two tables here, right? Cat and catOwner. And then the filtering predicate is cat.catOwner not equals to catOwner.id. And that less than greater than sign, that's just the not equals operator in SQL syntax. So just be clear what's going on here. We're creating a query object with the equality operator from these two field objects, and then we're using the tilde operator on the query object because the query class overloads the tilde operator to act as a negation operator, and that negation operator, the tilde operator, returns a new query object representing the negation of the query that we created with the equality operator. In the second example here, first we're creating two separate query objects with the equality operators. First, cat.catOwner equals catOwner.id, and second, cat.name equals mittens. So we have these two separate query objects, and then we combine them into one query using the ampersand operator, which produces a new query, a third query object, that represents the inner join of cat and catOwner with the filtering predicate of cat.catOwner equals catOwner.id and cat.name equals mittens. So it's a composite predicate here with two conditions, two equality tests. And both must be true for the whole predicate to be true. So it's selecting for only those rows where cat.catOwner equals catOwner.id and cat.name equals mittens. Any row in the joined table where that's not the case gets excluded from the result set of rows. Understand that in this example here, the parentheses actually aren't necessary because the equality operator has a higher precedence than the ampersand operator. I just included the parentheses for clarity. Now, our third example here is exactly the same as our second, just we're using the pipe operator instead of the ampersand. And so in the effective query, instead of the AND operator in the SQL, it's using the OR operator. So it's those rows in which cat.catOwner equals catOwner.id or cat.name equals mittens. So as long as either one of those is true, then the row is selected. Only when both are false does the row get excluded from the result set. And finally, in our last example, we're taking that same query, but we're just negating the whole thing. And note that does require placing the whole thing in parentheses and then putting the tilde in front. Otherwise, we would just be negating that first query, the cat.catOwner equals catOwner.id. We want to negate the whole thing. So note the effect of this in the SQL is to take that whole predicate expression and then just apply the not operator to the whole thing. So the end effect of this is to filter for precisely the opposite set of rows from those selected by the third query. So the logical operators of the query class, ampersand, pipe, and the tilde, the negation operator, be clear, they take in query operands and return a new query object. That's why in the first example here, actually those parentheses are required, because otherwise the tilde would be operating upon not a query object, but the first field object there, db.cat.catOwner, which is not valid because the field operator doesn't have a tilde operation. What's happening there is the equality operator of field is producing a query object, and then the negation is operating upon that query to produce a new query. Now, when combining queries using ampersand and pipe, it then becomes possible to get a query involving more than just two tables. And in that case, what happens simply is that all the tables are joined together, and then all of the predicates are applied. So here, for example, first it's again cat.catOwner equals catOwner.id, but then the second query we're anding to that is dog.name equals Fido. So what happens is first the table's cat, cat owner and dog are all joined together, and then we filter with the predicate cat.catOwner equals catOwner.id and dog name equals Fido. So the simple rule is that however many tables are involved in the query, they just get joined together first, then all the predicates are applied. Now, in the usual case of a request, in our model we open a database connection, and if in the course of a request we need to do any sort of database business, we use that connection to perform selects, updates, deletes, inserts, and so forth. And then at the end of a request, when we return a successful response, Web2Py will then automatically commit the transaction. If, for whatever reason, we need to explicitly commit our transaction, we can do so by invoking db.commit, assuming, of course, db is our connection object, which is, by convention in Web2Py, what we normally call our connection object. We normally assign it to a variable db. And then likewise, if we want to explicitly roll back our transaction to undo any changes we've made, we can invoke db.rollback. And as I mentioned earlier, there are circumstances where a rollback will happen implicitly. If an exception other than the HTTP exception is thrown and not caught in the course of processing a request, then an automatic rollback is performed on any open database connection. So it's not common that we invoke these methods explicitly, but occasionally there are cases when we would call them directly.